afternoon, everybody. Thank you very much. Oh, well, good afternoon, good morning, good night. Thank you all very much for joining us here for What's New with Compute in 2024, a story about UCSX and Intersight. First thing that I want to do here, folks, is just a couple of house cleaning items. First and foremost, we want you to be able to answer or ask questions, and I can answer them in line. So we do have a Q&A window here. So you can find that at the top of your screen under the ellipses, the three dots. It may also just be Q&A in your system bar for the Zoom session. Go ahead and pull that up. If you have any questions, go ahead and ask away. And if I can answer it in a timely fashion, I definitely will. With that being said, the next thing here is that we do have a couple of poll questions that I'll be filtering in during this tech talk. So please, if you could, we'd really appreciate it if you filled those out. We just got 3, not a big deal. It's like a yes or no, one answer kind of thing, right? So that would help us out immensely. We'd very much appreciate that. Then the next thing that I want to talk about is let's look at our agenda. So first of all, what I want to do is I want to talk about some of the issues that we used to have in the past. Believe it or not, technology hasn't been always bulletproof. We want to make sure that we discuss what moved us to where we are today. Like they say, you got to talk about the past to understand where you're going to the future. And so that's going to lead into the original solution, which I'll talk about, Project California, the 5108 series chassis, and some restrictions, some constraints that we had utilizing the 5108 series chassis and also the UCS manager. Then what we're going to do is we're going to look towards the future. How are we going to resolve all these past issues, move towards the future? And by the way, what do we got today? And what are we going to support for tomorrow? So with that being said, one of the first things I want to do here before I jump right in is I'm going to go ahead and launch this poll here. And so we're simply asking, have you deployed UCSX or are you planning to deploy? If you can go ahead and fill that out, we really, really appreciate it. Thank you. So I'm going to go ahead and jump in here. I'll end the poll here in a little bit. But let's go ahead and let's first start talking about the challenges of the past. So one of the biggest challenges was making changes with our hardware. And keep in mind that we're focused here on hardware in the beginning. Anytime we changed a fiber channel card out, or an Ethernet card, or a motherboard, or a hard drive, it caused issues. The reason being is because all of these hardware pieces, they live and breathe with an identity. That's how they're identified in the world of technology. Let me give you a quick example here and a problem that is created from it. So for instance, and got this really expensive whiteboarding utility that I love using here. In the beginning, what we were doing was we would have a network interface card on a workstation plugged into a switch. Very simple. Now, hold on, there we go. Now, here's the thing. A lot of the time for security purposes, there were things that we would turn on that could break by simply swapping out this network card. I know that sounds counterintuitive, but let me jump in here. There was this thing called port security. Port security, what it did was it said, let's look at the identity of this device. So from a network perspective, the identity of this device was in the form of a MAC address. That's its physical address. If you're not familiar with that, that's the media access control address, the layer 2 address. It allows us to find source and destination info. So when we plug this in for the first time, port security learns that MAC address and says, only, we'll just call it MAC address number 1, is allowed on this port. So what happens if this network card dies and I have to replace it with a new one? Here's the problem. This is going to get a whole new MAC address number 2. Port security says, I've locked this interface down to this one identity. When you plug in that new network interface card, it actually shuts down the port to ensure that there's no physical intrusions into the environment. That's just one of our issues. Another example could be whenever we install a motherboard and a hard drive in a workstation, we install an operating system on that hard drive. That operating system looks at the physical hardware of this motherboard and it identifies or it figures out its identity. So to the operating system, it has a whole different identity, and that's called a universally unique identifier. So what ends up happening here is, let's say I try and move this hard drive. Let's say the motherboard dies and I try and move this hard drive somewhere else. It's going to fail because when the operating system boots up, it says, that's not the identity of the hardware that I was originally installed on. Error, right? And that's where you get your boot failures. So a couple of other examples here. Worldwide no names and worldwide port names. This is for storage. Again, we usually map that UU or the worldwide no name, worldwide port name to a storage area. If that changes, so I replace my fiber channel card here. If I try and replace that fiber channel card, I got to create a whole new mapping. So what happens in the event of making hardware changes in the past caused a bunch of problems, right? So what we really needed to do is we needed to figure out a way to resolve this issue, right? Another thing that I want to make a mention of here is, and I'll talk about this a little bit later, but mid-plane overloading. In the past, a lot of our devices had these things called midplanes. I'll get to that here in just a second. But the biggest thing to note here is making changes caused issues just by replacing a network card, right? That was a pretty big bummer. So what are we going to do? What's the original solution here? Well, what we're going to do is we're going to take those identities right over here. So I'm going to take this identity, MAC address number 1, that lives on this network card. And you know what I'm going to do? I'm going to virtualize it inside of this thing called a service profile. Now, what I mean by virtualize it, it means that now this MAC address is in a line item of things, logical constructs, that I can apply to a whole nother device. By the way, to get into it a little bit deeper, Cisco developed this thing called a Cisco Integrated Management Controller on all of its compute nodes. So when I apply this service profile to compute node, it takes all of those line items and configures it for me. The integrated management controller will now go to that network card and configure that MAC address. So again, what happens if this entire workstation fails? Guess what? All I got to do is move that service profile over to a whole nother hardware platform. And you know what's even better? Is it's going to talk to that SIMC and it's going to configure the same MAC address. The beauty about this is now this is allowing us to recover from massive, massive failures, especially hardware failures, instead of it could take upwards of days to a week, 20 years ago. Now, 10, 15 minutes, right? I just reapply the service profile, reboot, it reconfigures, it's back up and running. I like that, right? And I don't have to mess with my storage, my networking, or any sort of motherboard hard drive related issues. That is a beautiful thing. Now, with that said, how was all of this managed? It was with the Unified Compute System Manager. This was originally a Java-based solution. Anyways, it's an interface that we used to manage the hardware of the solution and to create and deploy a server profile. So with that being said, Cisco's got this new SIMC thing going on. It's got this really cool new interface, and it also has unified hardware. The whole point of a unified compute system is that all of the hardware that's required to get you out servicing an application to a client is all in one box. This right here, what you're seeing on the slide, this is our original Project California. This is our 5108 series system chassis. Inside of it, each one of these, that's actually a compute node. That's a motherboard with CPU, memory, right? But also it had hard drives in the front. You could also do remote storage. And in the back, if we flip this around, it had a networking component. So we had everything, networking, compute, and storage all in one box. This was absolutely phenomenal. So not only do I have all of my components in a converged solution, I also have a management plane called UCS Manager that will allow me to manage this entire solution. Very neat. Now, looking towards the future, how have we updated this solution moving forward? And the first thing that I want to talk about is this beautiful 9508 series chassis. This is the X series. You'll notice in the previous slide, the servers were actually installed horizontal. Now we're actually installing them vertically. This is going to give us access to more hardware. In the original design, you could get 8 compute nodes in a 5108 chassis. We can still get 8 compute nodes in here. This example is only showing 4. These are just simply blanks. But we moved from a 6RU to a 7RU system when we updated to the X series. The reason why this is so important, it's allowing more hardware to be installed inside each one of these slots. By the way, I'm also going to talk about how we can get GPU and liquid cooling and optics a little bit later, because again, moving towards the future. Just to preface that though, optics and liquid cooling, as a heads up, folks, this has been available in this system since March of 2021. And then it originally came out, I believe, June or July of 2021. The beauty about this is it's already been tooled to support optics and liquid cooling, right? It can already support it, but we all went through a pandemic and a war and supply chain issues. So getting our hands on silicon and sheet metal was difficult. Plus, another thing is our power and cooling. With our cooling, we found with these, if we look on the back here, we see that we've got 4 100mm dual rotor fans. A lot of people look at that and say, I remember the UCS having like 8, right? It did. It used to have, the original 5108 had 8 fans, and they were bigger. They were 120mm dual rotor fans. Here's the neat part about this chassis. Right now, we don't even require liquid cooling, even though the Gen 4 M7s came out about 6-8 months ago. We still don't require liquid cooling because our air cooling is 1.7 times the air cooling that we had in the original chassis in the 5108, right? So that's pretty phenomenal. So we're still supporting optics and liquid cooling. We're just not needing it as of yet. By the way, another thing that we did is, our power here. So we actually used to have 4 2500 watt power supplies. We've moved to 6 2800 watt power supplies, and from a 12 volt to a 54 volt distribution for most of our components inside the chassis. Again, the reason why we want to do this is smaller fans at a higher repetition require a lot more power, whereas larger fans at a higher voltage at a lower repetition actually requires less power and provides more cooling. By the way, that's how we're getting the 1.7 times the cooling. Very cool, pun intended. Now, another thing that a lot of people look at, they say, oh, there's only 4 fans in the back here. Shouldn't there be more? There absolutely is. And so the first thing that I'll mention is each one of these cards you see here, they have their own function, but they also have 3 40 millimeter dual rotor fans. And each power supply has a 40 millimeter dual rotor fan. For us, what that means is there's actually 22 fans on this system. It's not just four like the original, 22 fans. Again, that's how we're pushing so much cooling. Now, let me talk about these modules here. If you're familiar with the unified compute system, in the past, I mentioned that we had networking integrated into that box. That's exactly what this is. This is our intelligent fabric modules. These are actually, uh, think of them as an Ethernet card for each one of your compute nodes. This is beautiful, right? So each compute node gets its own interface depending on how you plug it in. But notice there's two. This is going to give us a side A, side B for redundancy and failover and load balancing. We love that, right? Now, down at the bottom, these are our cross fabric modules, XFMs. These are really neat because what they're actually doing is providing access to GPU connectivity. A graphical processing unit is something that we haven't had in the past. Now I have the ability to take an entire slot right here and fill it up with like A100s. If you haven't seen an NVIDIA A100 GPU, Google it. It's a pretty intense graphical processing unit. We can use it for things like artificial intelligence and machine learning, which hence where we're moving to in the future. Okay. Now, one of the things that's incredibly important about this new box here is there's absolutely nothing inside that box. The traditional 5108 chassis had a mid plane where the computes would plug in to the mid plane on one side, and then your networking constructs, your input output modules at that time, would connect to this mid plane. We've removed that. Why is this so important? Because moving forward here, all of your components are now going to plug directly into each other. This is going to free up a lot of space inside the chassis, again, to provide additional cooling. I love that. Because again, we don't just have CPUs and memory and all of that here. We can have up to 8 NVIDIA A100 GPUs. That's going to require some cooling, right? So we removed the mid plane, and there hasn't been a back plane for a long time. By the way, another important feature, kind of a selling point here is that this is infinitely forwards and backwards compatible. Right now, we're in the 5th generation hardware of the UCS X system, but there was a 4th gen. The original came out in June, July of 2021, and then the following year, roughly about a year later, we came out with the 5th generation hardware. So we're already supporting 4th and 5th gen hardware backwards and forwards compatibility. Now, what I wanted to do is just really quickly share and compare the difference between our original 5108 chassis and the 9508. I already mentioned we went from 6RU to 7RU. We went from 4 2500 watt power supplies to 6 2800 watt power supplies, from 12 volt to 54 volt distribution. One thing I did not mention is the way that we have our power configured. Guess what? You may be familiar with N+1 and NN, or in other words, non-redundancy. N+1, a node with one backup, and then grid redundancy, where we have a node that can use any power supply as a backup. But notice we have this N+2. This is neat. Now a power node can have 2 backups, one inside its primary controller and one inside of a secondary controller. That is an amazing advancement, right? Talking about the life cycle and the future of compute, right? I already mentioned the 22 fans here in the back, right? By the way, if you're not familiar with cubic feet per minute, that's just the amount of airflow that I'm pushing. The original 5108 chassis could push 590 cubic feet per minute of airflow. Whereas again, by reducing that mid plane, we can now, and with all our fans, we can now push 100,000 cubic feet per minute. that's that's pretty intense. Now, on the networking side, what's beautiful is we did not reinvent the wheel. We still have the same constructs. If you folks are familiar with the chassis management controller and the chassis management switch on an input-output module, if you're familiar with that, it's exactly the same. We just changed it to 25 and 100 gig. That's it, right? They're still doing the same thing. The chassis management controller is still looking up and identifying which fabric interconnects it's connected to. Now, another thing that I want to mention here, last thing here on the slide is PCI Gen 4. When some of the components were originally developed, they were PCI Gen 3. By the time we released this into the wild to the public, everything was PCI Gen 4. Or PCI Express, excuse me, Generation 4. This is equivalent to 1.8, 1.9 gig per PCI Express lane. So very, very nice. By the way, with our 5th gen hardware, I'm pretty sure you can guess, we're supporting PCI Express Generation 5, which is getting us 3.9 gigs per PCI Express Gen 5 lane. Very, very neat stuff there. Now, with that being said, we've got all of this really neat, brand new hardware. How are we going to manage it? Well, I do want to mention that there is an option to manage the X-series with UCS Manager, but that's a relatively new solution. Let's talk about the original management interfaces. So we have our Intersight SaaS solution right here. By the way, this is simply living inside of an AWS region, East right now, right? We are opening one up in Germany. There is going to be I believe we've already opened up the West one. So we're expanding the AWS regions that SaaS is deployed on. By the way, if you're familiar with any sort of client server model, your AWS component is simply a Redfish server. That's it. It's a Redfish server living out on an AWS region, and you attach this thing called a device connector to that Redfish server. That's it, folks. That's the whole management, right? Now, we have a SaaS solution. So that's an online dashboard. And by the way, just real quick, I'd like to show you that dashboard. So just a quick, jump through here. We can use this to manage our hardware, like our fabric interconnects that get us out to the rest of the world. The chassis. This is our X-series 9508 chassis, fully loaded. If we flip it around, you can see we've got our network configured, plugged in. There's those our 4 fans, and then our cross fabric modules. And then, of course, the most important piece is our compute nodes. Yes, I'm working on a troubleshooting course, so some of them are broken. But if we drill down into these machines, we can see the physical location of that compute node. By the way, you can also click top and see CPU and memory installation. And we can even go into inventory, and we can see all the individual devices that are connected, like our network adapters and storage controllers. But that's not it, folks. There's 2 other things that I really want to talk about here, and that's our profiles. A couple of things that we did not have in the past. The UCS Manager, if you're familiar with it, you had to click around in a bunch of different places. Whew, I did not like that. Now, what we've done is I'm actually just going to click Create here and click Next. And what you'll see here is this thing called a domain profile allows us to go through all of the standard things that you would be configuring as soon as this solution came online. But you'd have to go to like Equipments tab, Server tab, LAN tab, right? SAN tab, Admin tab, and you're always bouncing back and forth. Wouldn't it be nice if we just put everything in one wizard, and when you were done, you click Deploy? That's exactly what we did. With a domain profile, you're configuring your fabric interconnects, discovering your chassis and your compute nodes, all in one action. By the way, once you've done this a couple of times, it takes you 5 minutes to run through this, right? Now, with that said, the server profiles, guess what? Again, we did not reinvent the wheel, right? So a server profile is the exact same thing as a service profile. The only difference here is moving into the future, we've got really neat things called LAN and SAN connectivity policies that are just like the domain profile. I want to make sure that everything LAN related is in one wizard. Everything SAN related is in one wizard. I like that. It's a beautiful thing. So that was just a quick crash course on profiles. The other thing that I wanted to mention here, and let me see here, is now we have tons of metrics that we can identify. Let me clean this up here. So from a troubleshooting perspective, there's way more here in Intersight than before, than in the UCS manager, right? So there's way more stuff that we can troubleshoot. And then I guess one last thing is our targets. Not only can we see things like your UCSX and your original UCS chassis, but you can also claim all of these third-party utilities, VMware, AWS, UCS Director. Oh, didn't I see the APIC over here? Yep, Cisco APIC for Application Policy Infrastructure Controller, right? So, and there's a Redfish server that's been around since 2015, 2016. If you've already got one built, you can go ahead and bring that policy automation right in. So with that being said, we've got two other options. These two are for on-site deployments. The connected virtual appliance, it looks and feels exactly like your SaaS dashboard. The only difference is you install it on a virtualization platform inside your organization. So you're not using an AWS region. This is going on your vCenter deployment, right? And we're doing the same thing. You're creating a Redfish server that's going to connect to the equipment. Now, the connected virtual appliance allows us to pull things down, which is really, really nice. But the Intersight private virtual appliance, this is completely air gapped. We have this for a lot of our government and federal and some military. You know, they don't want their management traffic getting out. So this is completely air gapped. So yeah, if you want to update firmware, you're gonna have to go put it on a USB drive, plug it in, you know, do it the difficult way. But it's obviously the more secure method. There we go. Okay, now, one of the last things that we want to mention here is the 5th gen and 4th gen topologies. What can this solution support? So for anybody who's familiar with the C-series, and I'm going to get a little technical here, but with our C-series right now, we're predominantly supporting the M5, M6, M7s with the C220s and C240s. And this is our direct attachment. So you can still plug directly into the fabric interconnects. With the C-series, you can also still continue to use your fabric interconnects. If you want to get up to 100 gig, we're recommending the 93180 for 100 gig. That's the 3rd gen fabric extenders. They plug in, operate exactly the same way. You just make those ports server ports, done and done. Here's your 5108 series chassis. Yes, we can plug it into our or our 5th gen fabric interconnects and operate it alongside of our X series and manage it with Intersight. The big thing to note here for anybody who's getting ready to do a deployment is the 2408 input output module. We do support the 2204 and the 2208, but I would say post first customer shipment, please make sure that you are on a 2408. The 4th gen input output modules, those are just, it's just going to make your life a lot easier, right? Then the original 4th gen hardware had 25 gig network connections up to the fabric interconnects. Our 5th gen, we updated to 100 gig. By the way, moving into the future, we're starting with 100 gig end to end, right? So that's our starting point. Now, with that being said, another poll question that we have here is, what is some of the compelling events that are driving you towards transitioning from the 5108 chassis to the 9508? It might be that you're creating an on-prem cloud, like I just mentioned, or you need larger resources. So I need GPUs, I need higher level, higher end CPU and memory, right? So I'm going to go ahead and launch this poll. Again, folks, if you could please fill that out, we'd really appreciate it. Now, what's on the horizon? And that's where artificial intelligence and everything comes in. So the first thing is artificial intelligence and machine learning. You know, we all heard the buzz, right, at the beginning of last year. Chat GPT, yay, right? More and more organizations are moving towards their own privatized artificial intelligence and large language model to boost productivity and performance of not just their applications, but also their workforce. So a lot of people are moving towards artificial intelligence. Another thing here is, again, as I mentioned, hardware, right? Liquid cooling and optics is coming. Hint, hint, wink, wink. Watch in June or July, right? Uh, so we're definitely wanting liquid cooling for higher end GPUs. Again, we're supporting the full line of NVIDIA A series. So you've got your A16, A40, A100. We're also supporting the Tensor T4 core GPU, and we're also supporting the Intel L and H series. So we have a wide array of GPUs that are supported in this solution. And I don't have enough time to talk about it today, but I want to let you know I can get 24 NVIDIA Tensor T4 core GPUs in just one 9508 series chassis. That is absolutely insane. So 24 GPUs. Yeah. Without liquid cooling right now. That's pretty neat. Another thing is Nutanix. Right now, what we're doing is we're building the hardware platform for a hyper-converged virtualization platform. Previously, we had Hyperflex. Cisco is now partnered with Nutanix. And so Nutanix is going to take over for that new hyper-converged infrastructure. So this is like a virtualization platform. It is using vSAN for vCenter for storage, right? So it's converging not just the hardware, that's called a converged environment. We're converging the software into the hardware. That's called hyperconvergence. And then the last thing here is multi-cloud, right? We want to be able to have flexibility. I want my on-site on-prem cloud that I manage, but I also want to have maybe a backup or a 24/7 always ready uptime availability, 5.9 uptime availability with a cloud implementation, right? AWS, Azure, Google Cloud Platform. So we want to make sure that moving forward, we're supporting that flexibility. So let's jump in. I just got a couple more slides here, folks. I'm going to go ahead and end that poll. One of the things that's very, very important that I show you, GPU connectivity. So here are your, your A and T series from NVIDIA, like I mentioned. But I can get 4 Tensor T4s in each one of these slots. By the way, this is a whole different node. This is our X210C compute node. That's what does standard application processing. In all of our odd numbered slots, we support a processing node, the X440P. That's what's supporting the GPUs. So you pull that thing out, set it on the desk, and you can install up to 4 Tensor T4 core GPUs. They do ride along these cross fabric modules from the compute node to the processing node. So yeah, the slot number 1 is going to be using slot number 2 for GPU connectivity. It's pretty neat. Again, some of the workloads that are moving us towards things like liquid cooling, higher level GPUs, front side acceleration. Obviously, it's going to be machine learning, right? Low latency processing, obviously, is always going to be a big one, but with that being said, I want to show you just a soft roadmap. As of 2024, we are looking to start liquid cooling your GPUs around June or July. Soft roadmap. We don't know if that's going to happen just yet. You never know, right? What happens in the future. But then by the end of 2025, I want those CPUs and GPUs also liquid cooled. And then by this looks like it's the end, but probably mid 2026, you're going to have your FPGAs, your front side graphics accelerators, your graphical processing units, your central processing units, all going to be liquid cooled or have the capability of it. Again, you do not have to get a new chassis. It's already tooled for liquid cooling. We don't have to worry about that at all. Love that. Now, as I mentioned before, this is just a summarization. Nutanix, it's a cloud computing software company, essentially combining compute, storage, and networking into a single integrated system to reduce data center complexity and increase scalability. Like I said, it's a hyper-converged solution, right? And then the last thing here, I did mention this, but we do have third-party integration. One of the things you have here with Intersight is you have this thing called an Intersight Assist. This is actually a little appliance that can live on OVS, vCenter, SCVVM, right? System Center, right? But all it's doing is creating a device connector that's going to communicate up to Intersight. So just like our X-series natively supports this device connector, you have the ability to install these device connectors into things like VMware, Pure Flash Storage, NetApp, generic HTTP for monitoring and maintenance, Hitachi. By the way, we do have Flash stacks, Hitachi stacks, FlexPods, vBlocks, all CVD'd, so they are a Cisco validated design. And that's how we're providing that Cisco validated design through Intersight with the X series. We're simply installing an Intersight Assist agent, and that's it, right? So with that being said, I do want to launch one more poll for you. Since we were talking about some of the future advancements and some features, what feature are you most interested in taking advantage of moving into the future, right? Unified monitoring and management, security, automation, and workflows with our workflow designer and Intersight, inventory information, capacity planning. Oh, hold on, my bad. Hold on, let me relaunch that poll, excuse me. Okay, so I went ahead and launched that poll. If you could go ahead and fill that out, we'd really appreciate it. Thank you so much. And with that being said, one of the first things I want to do is talk about our training offerings. So I'm going to go ahead and take this and I'm going to go ahead and post a link to our training options here in the chat window. So at sunsetlearning.com, you can go to our UCSX training. We've got this nice little video. It's going to talk about what the training options are. So right now, what we're working on today is our UCSX DOT, which is Deployment Operation and Troubleshooting course for Unified Compute System X. This is actually a 5-day course, by the way. We're hoping to take CLC, Cisco Learning Credits, if that's something that you folks can pay with. And another thing is that you don't have to take this in a 5-day, traditional format. We can actually split this up across multiple weeks if you need to. That's something that we're looking into being able to do for you and our partners. By the way, if you click here on the UCSX dot, you can see it's a 5-day, 45 learning credits. Download the course outline, and then you can also register for classes. Now, with that being said, I want to leave you with some sort of swag, right? So here's your swag. 20% off the UCSX Intersight Deployment Operations and Troubleshooting course. If you use that UCSX20 code at checkout when you register for the course, you get 20% discount on my 5-day UCSX dot. And thank you very much for your time, your energy, and your presence. Thank you.
If you like this video, don't forget to subscribe and click on the notification icon to get notified whenever we upload new content.